Bienvenidas al podcast IoT Futura, una tertulia tecnológica sobre el Internet de las Cosas y otras tecnologías relacionadas. Este es el primer capítulo de la segunda temporada. Lo estamos grabando el 18 de octubre de 2021, que como hemos hecho en otros capítulos, siempre nos parece buena idea decir la fecha, sobre todo cuando hablamos de tecnologías muy nuevas, ¿no? Para que cuando se oiga un poco más en el futuro se sepa de en qué momento se estaba grabando el capítulo. Hoy vamos a tener una conversación muy interesante acerca de los coches autónomos y las arquitecturas en la nube que lo hacen posible. Y vamos a tener una charla técnica muy buena con una novedad además muy importante porque se va a hacer en inglés, nuestro invitado habla en inglés y bueno, nos va a forzar, sobre todo a mí, que me cuesta un poco más de trabajo, a hablar en inglés, a entenderlo y ya veremos cómo luego editamos todo el vídeo y el audio y ponemos una voz en off y subtítulos y bueno, es todo un reto. Como sabéis, y si nos seguís hace algún tiempo, podéis ver y oír el resto de capítulos yendo directamente a la web iotfutura.com/podcast. Allí encontraréis la información de todos los capítulos y los enlaces a iVoox, YouTube. Y también todos los links a las recomendaciones que hacemos al principio de cada capítulo. Si queréis también podéis seguir la cuenta en Twitter, @iotfutura, donde todos los días se publica una colección de pequeños artículos relacionados con el IoT y con las empresas y con el mundo relacionado alrededor del IoT, que son bastante cortitos y muy interesantes de leer. También nos hace bastante ilusión que os suscribáis a estos canales, tanto a Twitter como a YouTube, a iVoox, pues porque vemos que el número va creciendo y que le va interesando cada vez a más personas. Nos hace ilusión teneros de seguidores. Además de seguidores, podéis participar activamente, tanto escribiendo los artículos del blog, que están abiertas las opiniones y está un poco moderado para que aquí no se cuele el spam, ¿vale? Pero están abiertos todos los comentarios. O en iVoox o en el propio vídeo en YouTube también podéis hacer comentarios. También, si queréis, si tenéis alguna sugerencia, algún comentario, algo que criticarnos, algo que hayamos dicho mal, corregirnos, lo que queráis, podéis escribir a podcast@iotfutura.com. Hoy estamos en Petit Comité, tenemos a Félix Ontañón, que ya por supuesto que es el habitual nuestro de siempre y es ya nuestra alma mater, está siempre con nosotros. Hoy trae una camiseta que a mí me hubiese gustado traerla también, pero hemos tenido un pequeño problema logístico. La camiseta esta que está luciendo que pone, son 3 símbolos químicos, no ni na, no ni na, en la triple negación, que se convierte en una afirmación del novelio, el níquel y el sodio. Pero es un emblema del proyecto que, al menos uno de los líderes de ese proyecto, de andaluz.es, en defensa de la lengua andaluza. Félix, ¿qué tal?
Pues estupendo, Juanma. Muchas gracias por invitarme otra vez. Me estás haciendo queda un poco como el pesadito que se une siempre. No sé qué
No, no,
pensará
no,
el
no,
resto de la
no.
gente.
Tu presencia ya empieza a ser necesaria siempre, Félix.
Gracias, Juanma.
Eh, Tenemos también a Guillermo Amodeo. Con Guillermo podríamos estar hablando horas sobre tecnología, anécdota que tenemos juntos, su lado artístico, el lado artístico de su familia. Guillermo necesitará más de un capítulo posiblemente
No,
para
no, me
hablar
encantaría.
de todas las cosas que es capaz y que seguro que nos va a aportar. Hoy viene por primera vez al podcast, porque además el invitado que vamos a presentar a continuación es amigo suyo. Y yo creo que nos va a tener que echar una mano sin que sea una traducción simultánea cuando me atasque un poquito con el inglés y se me vayan las palabras un poco raras. Guillermo, ¿qué tal?
Bueno, bien, bien, como te digo, igual que dice Feli, gracias por invitarme, aunque yo ya sé que Feli es un erudito, yo voy a intentar hacer lo que pueda, pero como dices tú, no me callo debajo de agua y entonces, ni debajo de agua como dice mi madre, Y claro, conmigo se puede hablar mucho, pero soy bastante educado en las tertulias. Soy bastante educado en las tertulias. En Nerva no tanto, pero en las tertulias sí. Y entonces, pues sí, te agradezco mucho que me hayas invitado. Tú sabes, yo sigo los podcasts, los veo. Y, hombre, y está aquí es un poco un honor, ¿no? Y, hombre, y además compartí un rato con un personaje tan importante como el que ha venido hoy, ¿no? Entonces, pues, muchas gracias, muchas gracias.
Encantado de verte. Bueno, nos conectamos todos desde Sevilla, tanto Félix como Guillermo como yo. Y lo que vamos a hacer va a ser dejar a nuestro invitado un poco al margen para luego hacer la presentación de él y entrar directamente en el tema. Vamos a hacer la parte de recomendaciones iniciales que solemos hacer un poquito rapidita para no tenerlo a él aburrido. Y si os parece, pues Félix, dispara.
Bueno, pues yo la recomendación que os traigo para hoy, si habéis visto otros episodios de IoT Futura, si no, por revisarlo, normalmente traigo cosas bastante raras, friki, movidas que nada más que me gustan a mí. Hoy traigo una cosa un poquito más generalista, aunque clásica, y es que os recomiendo, si no lo habéis leído, que leáis El Lazarillo de Tormes. Me he comprado este volumen que ha editado la Real Academia Española porque El Lazarillo de Tormes en realidad es un libro que tendrá esta dimensión, pero todo esto son las anotaciones metodológicas que me estoy cargando porque estoy trabajando un poquito en una adaptación de esta obra. Pero
Al andaluz.
eso es otra historia. Por ahí van las cosas. Eso es otra historia. La cuestión es la siguiente. El Lazarillo de Tormes forma parte dentro de la literatura, perdón, dentro del el currículum lectivo en literatura española. Está en secundaria, yo no sé ya, por lo menos cuando yo estudiaba en el BUP, también en la universidad, y realmente lo que me he dado cuenta haciendo el trabajo de adaptación a esta obra es que si con esa edad que estamos en secundaria o que estamos en el BUP, que estamos en la universidad, hemos leído El Lazarillo de Tormes, entonces no hemos leído El Lazarillo de Tormes. Esto es una obra que exige que seamos ya treintaitones o cuarentones para entender lo enrevesado, rebuscado, interesante y magistral que es esta obra que todavía a día de hoy nos puede dar muchas lecciones sobre cómo somos la sociedad española. Así que ahí va mi recomendación.
Estupendo. Es una edición un poco especial entonces por todas esas anotaciones, ¿no? Vale.
Sí, el libro es muy cortito en realidad.
Pondremos el enlace en el canal de IoT Futura barra podcast en el episodio. Yo recuerdo haberlo leído de joven, yo creo que ese libro sí que nos
Lo hemos leído
obligaron,
todo en el colegio, lo leído
nos obligaron a leerlo, porque a ti te
Entonces
obligaban
no lo
a
hemos
leerlo.
leído, si es que ese es el problema. No lo hemos leído porque no tenemos edad para leerlo.
Efectivamente.
Yo he de
Pero
admitir que me pasó con el Quijote. De hecho, tengo una versión que me regaló un amigo con ilustraciones de Gustave Doré. Yo soy un amante de las ilustraciones de Gustave Doré. Y la verdad es que llevas mucha razón. A mí me ha pasado, yo también he recuperado un libro. No es realmente yo no me he preparado ninguna recomendación porque me ha cogido un poco así, pero sí, también recomendaría otro libro del mismo autor que se llama Rinconete y Cortadillo, que lo he leído de mayor y es realmente divertidísimo. ¿Vale? Pero vamos, yo en ese sentido estoy absolutamente de acuerdo contigo, Félix. No leímos un montón de libros, Platero y yo, ¿no? Esto, lo otro, y nunca los hemos leído realmente.
Platero y yo, si lo leíste de joven, tampoco lo leíste.
No, tampoco.
Juan Ramón Jiménez no es fácil.
No.
hay obras que es verdad lo que tú dices, que pueden estar disfrazadas de una aventura un poco ligera y simple y graciosa, pero realmente la obra no va de eso. ¿Eh? Y probablemente esas obras clásicas que nos hicieron leer cuando éramos pequeños no le sacamos el jugo que realmente tiene la obra, ¿no? Es un poco también pasa. Yo el Quijote no lo he leído entero, tengo ahí, lo tengo a media, pero pasa un poco eso, ¿no? Que la aventura propia del Quijote es bastante simplona, por lo
Muy
menos lo
divertido.
parece, pero cómo está escrito todas las historias y todo
Es
lo que
muy
dice,
divertido.
sí,
Es bárbaramente divertido.
pero es una crítica muy audaz de toda la
Hombre, lo
sociedad.
que pasa es que nos falta, por eso está muy bien lo que ha dicho Feli, en la versión anotada, porque claro, ten en cuenta que, por
Sí,
ejemplo,
sí,
o sea, cuando tú lees una sátira, tú te tienes que tener el contexto de la situación, ¿no? Es como
efectivamente.
todos hemos leído la sátira de Quevedo, las peleas entre Quevedo y Góngora, pero si tú no las pones en contexto, no las entiendes, ¿no?
Sí, incluso hay mucho vocabulario que a día de hoy le damos significado distinto que en aquella época tenía otro. y induce a confusión la propia lectura de los
Ujú.
párrafos. Tener una versión anotada me parece fundamental para intentar acercarte a lo que está ocurriendo, que si no es que hasta te puedes perder. No demasiadas veces en el lazarillo, hay que decirlo, pero sí algunas, y te pierdes algunos detalles de los que son maravillosos.
Que tenía más hambre el lazarillo.
Muy
Esa es
bien,
la
muy
línea, esa es una línea continuista a lo largo de todos los tratados del lazarillo, pero
Bueno.
Bueno, pasamos a mi recomendación y es que me preocupa tener a nuestro invitado ahí.
Por eso, ¿no? Yo te iba a decir, vamos.
Mi recomendación es muy rapidita, ha sido un poco de casualidad, viendo un vídeo de Jaime Altozano, que es muy conocido en YouTube por cómo explica la música de todo tipo, ¿eh? Y cómo explica cómo funciona el sonido, cómo funciona el lenguaje musical, cómo funcionan las anotaciones, cómo funciona todo. Y el otro día vi un vídeo suyo explicando la historia que hay detrás de las 4 estaciones de Vivaldi. Y me pareció fantástico, porque las 4 estaciones de Vivaldi, los instrumentos hacen y representan a personajes dentro de esas 4 estaciones, primavera, verano, otoño, invierno. Y hablan de cómo se hace la caza, de cómo está persiguiendo a la liebre que sale corriendo, o de cómo celebran los campesinos borrachos una fiesta en otoño, o de cómo se resbala la gente en el hielo en invierno. Y me pareció alucinante. Tengo pendiente porque son frases que están escritas en la propia partitura original de Antonio Vivaldi, obra escrita a principios de 1700, 1721 así, he estado leyendo, tardío barroco, barroco tardío. Y muy interesante porque yo no conozco la música clásica. Mora nos aconsejó hace algún capítulo una ópera y la verdad es que quizás nos falta mucha educación al respecto, ¿no? Y yo creo que a lo mejor una buena forma es empezar por YouTube con vídeos como los que hace Jaime Altozano, que son fantásticos todos, y te enseñan todo lo que es el lenguaje musical y me gustaría pararme un poco más y en los enlaces que os pongan en el capítulo hablaremos sobre, o sea, os lo pondré sobre
Yo sé la ópera que te recomendó Mora, que es su favorita. Él y yo tenemos, la mía es Turandot y la suya es la flauta mágica.
Sí, correcto.
La flauta mágica es, y precisamente el número que a él más le gusta es bárbaramente increíble verlo en vivo.
Yo creo que nos falta mucha educación básica en nuestra niñez para acostumbrarnos al lenguaje de la música.
Mira, yo, como te digo, no traigo recomendaciones y voy a decir una cosa rápida precisamente a eso. Nos falta mucho la educación porque, mira, yo a mi hija me la llevé cuando era pequeña, tendría 6 años, me la llevé a ver un concierto para ella, que era un concierto se llamaba Los Clásicos Divertidos, que eran música divertida para niños. Nos sentamos con ella en el concierto y se durmió. Y le digo, ¿pero por qué te duermes? Y dice, porque es lo que hace uno en los conciertos, se duerme. Porque es lo que sale en los dibujos animados. Y se durmió. Y entonces, pues, pero...
Yo creo que habría que, no sé en qué momento de la infancia y de la adolescencia, pero dar mucha más caña con la música, Bueno,
Venga, vamos a hablar con Gaps.
Okay, time to introduce our guest, our special guest of today. His name is Gabriel Sala. Guillermo introduced me to him as Gabs, so we are going to call you Gabs if you don't mind, Gabriel. You are connecting from Dubai. I don't know what time is there right now. But
late, very late.
It's very late, a few
3 hours, no ahead, no?
Yeah, 2 hours ahead, but it's normal for me. My morning are quiet, evening are busy. It's okay.
Thanks a lot for being here at this time. Gaps is an architect, a cloud architect, an infrastructure architect. He does cloud infrastructure by code. It means that he is able to program and develop all the architecture using a language, a programming language. His main job right now is doing autonomous driving car simulations for a few companies, a few car companies with the Microsoft Cloud. So Gabs, what is your job right now? What is your role in the projects?
Sure, thank you, Juanma, and it's a really pleasure to come with you guys and share what I do and learn from you. Hopefully we'll have a lot of discussion. So what I do today, I work in a team in Microsoft where we spend times with car makers. So you know that a lot of the car makers, so call it Volkswagen, Renault, Seat, all are thinking about building these autonomous driving cars. So these cars where you don't need a driver, you just sit down, it takes you from A to B. But for that to happen, all these car makers, they need to test these cars. So I'm sure you see in cities, some of these vehicles, they have like sensors, cameras on top of these cars that basically taking picture of the environment. So buildings, people crossing the road, traffic lights. And for a car to understand all this, you need to capture all that information. It's just like a movie producer. So he's filming what's going on into the movie. And then once you get the movie, you take it to the cloud. And then in the cloud, you use that movie to train the machine learning model that you're going to put in the car. So the model needs to do exactly what the driver does. So there's a traffic light. The model say, put the brakes on the car, everything stops. It's raining, or you need to reduce the speed. So everything that, again, a driver does with autonomous driving, you're trying to try to copy it, try to simulate it. And for us, what we do, because it takes a lot of time to capture this information, and it takes a lot of data. All the car makers, they will have maybe 6 or 7 of these cars in a city. They drive around, they collect data. And all this data is what's happening. Someone crossing the road, does a car stop? Or there's a car in front of it, what happens? So you're just recording what is the car doing in a normal city. And we know that, again, driving is a very complex activity. I mean, for us now, you drive a car because you've done it all your life. It's very easy. But for a computer, remember computers, you need to use things like computer vision. You need to use a machine learning model to train the car to recognize an object. So object detection. So there's a lot of techniques that you need to train your model so that you understand, again, the model understand what they do, what the car is doing, so that in 2 years' time, you can have these cars, you call them with your mobile phone, the car comes in front of you, pick you up, take you from Seville to Malaga without a driver. That's the goal. So in my job, I help these car makers to train these cars so that they become autonomous. You don't need to have a driver inside. And today I will share some of the technologies we use to essentially build these test vehicles in the cloud. How do you simulate it? What technology, what hardware, what IoT device do you need in the car? And also, how much data do you need? I mean, it's a lot of, when you think about it, when you record on your phone, you record a movie, 1 second, like it's nearly, again, not even 1 minute, it's nearly a gigabyte of data, depending on the camera definition. So all that is important in terms of autonomous driving. What type of camera they're using, they're putting on top of the car. I'll show you.
Let me just 2 questions. How do they, because you have already in a vehicle a few autonomous systems or subsystems, because you have auto braking, where they see a person crossing the road, or they put the swipes when it's raining. Swipes is the word? Yes. No. Swipes. Rain swipes.
Wipes.
Sweepers.
They are called sweepers or wipes.
Wipes, rain wipes, automatically, or the lights, or are all these systems as well being automated, or they will rely on the already existing ones.
Yeah. So what you have in terms of autonomy is there's different levels. Level 1, level 2, level 3, level 4, level 5. So today, most cars are level 1 and level 2. And what you describe is like, again, lane changing or reverse parking. So these are level 2. Level 3, again, so things like cruise controls, all these are level 2 level. Level 5 cars, again, none have been designed yet, but it's basically a car, there's no wheel. You come in, you sit down, and it takes you away. So that's the goal. Everybody wants to go there. I mean, you see company like Tesla, they say, oh, well, we are fully autonomous, but yeah, sometimes, yeah, not really, but maybe it's in the marketing, we don't know. But the customers I work with are mainly working in level 2, level 3, and applying level 4. And as you go in terms of level, what's very important is it becomes much more complex, because as you become more autonomous, you need to have more information. So your camera, your sensors, your LiDAR, so for the distance detection, become much more precise. It's just like a video camera. So you have, I don't know, 720p, you have 1080p, you've got 4K, you've got 8K. You have the same thing on the sensors that sit on the car. So because the more definition you have, it gives them the model much more precise information. And then it becomes a big data problem, because
how you know, one of the things that Juanma mentioned, and I think is really, really important, because I'm a passionate of complex systems, you know, and one of the things I always see as probably the more complex part of an autonomous driving function is actually the event management. How do you manage the events? Traffic light going on. I mean, especially when events are kind of simultaneous. You know, you are getting to a crossing road, and then there is a ball coming down, and then there is a kid behind the ball, and you know, and that sort of event management is kind of because I mean, computers are not very good managing unknown events. You know,
yes,
and this is something it could really happen. You know, maybe
that's
we are going ahead your
point.
presentation, but you know, I mean,
No. That's a good question, because we move away from event to you actually train. You train the model so that when that event happens, they know what to do. So you do, like, again, there's some terminology called supervised learning. So I'm learning again, if a ball goes across the road, you see it 10,000 times, you realize that, okay, you need to put the brakes. So you move away from event handling to actually learning, just like a kid learning to play tennis, or a kid learning to, I don't know, ride a bicycle. They will try, they'll fall,
So we are talking about not about machine learning, but the real intelligence, artificial intelligence.
No, it's machine learning. Machine learning.
Because you're talking about predicates. You are talking about, you know, you get a predicate, you have a reasoning behind, all right? If this is that, then that is this, and then the model is able to actual reasoning that if it got 2 legs and it got a head on the top, is vertical, and meets that, is a man. You know what I mean?
Yeah, exactly.
And like that is the same thing, but shorter. Then that must be a kid.
Exactly. So you're learning from images. I mean, you'll see 10,000. I mean,
so everything
that's
is based
why
on
it's
images.
so important. It's so important to capture as much data as possible. So when you see this car driving, sometimes some of the data is not interesting, because it's like you're on a motorway, you're driving from Barcelona to Seville, straight line. There's nothing. There's sunshine. But you drive inside the city, there's traffic lights, there's people running the road, there's people running in a bicycle, there's people jaywalking. So there's more events that you need to deal with. So that's why it's so important when these cars are driving, they're driving in areas where there's a lot of complexity, because that complexity will allow the machine learning model to say, okay, what do I do in an event of this lady crossing the road without looking at the traffic light? So complexity, I mean, yeah, but for complexity, you need a lot of horsepower, you need a lot of compute. So that's why, again, what I've been doing in the last 30 years is building this large scale compute farm, high performance computing. So I worked in many projects. I worked in one of the biggest projects in Spain at Mare Nostrum, University of Catalonia, when they were building this big high performance computing, and they use it for design, for
inside a church.
Research, yeah. Even for they were designing, use that to design CPU. That was like, I don't know, 2000, nearly 20 years ago. But technology, how it improves at such a pace that it's crazy. I mean, the technology that we deploy is not on one machine. We're talking about 60,000 cores.
Right. So
solve a single problem.
So basically, the infrastructure to run just one car is very big, no? Because
we're
talking about the difference. There's a difference between, you know, the different levels of management. You know, the events that happen. Juanma was mentioning about. All right, it's raining. I need to activate the wipes towards. All right, there is a traffic light. I need to stop. All right, but I am reversing. I need to switch on the intermittent. Those things I guess they are automated by the car itself, and it shouldn't be actually in the cloud, or
not by the car. So the typical use case. I mean, let me show you the end-to-end architecture. Let me show you that. Then that will give you a better picture of what I mean. Just I need to see how this share. How does I share my screen? Oh, host. Disabled partisan. I cannot.
Oh, sorry. Moment.
He wanted to make me chat on the chat instead me.
I should do the same with the mic, I think, with the mic. Okay, now it's set to all the participants can share, so you should be able to share.
Okay, 1 second. Share my screen. Okay, where am I? Yeah, this here. You see my screen?
It's coming.
It's coming. Yeah.
Yes.
We can see that now.
Yes, we are seeing.
So let me put it properly in presentation. Okay, is this better?
Yes, much better.
Mm-hmm.
So this is what we call AV ops. So you guys have heard about DevOps. You have heard probably about data ops, ML ops, machine learning operation. But how do you build a tool chain for autonomous driving cars? And for us, again, and for, I mean, as I say, this is agnostic. Any other provider, cloud provider will have something similar. So you have these different components will allow you to build. Essentially, what you're building is a test platform where data can come in, and you use data ops to manage the data, to clean the data, to keep the data that you need. Because as I say, when this car drive, they go around driving the city, they come back with tons of data. For on average, per car per day, you can have like 20 terabytes of data. You have 10 cars, that's 2 petabytes of data a day that you need to bring to your cloud to process. The reason why you bring that data to the cloud is essentially when the car drives, it uses all these different sensors, so the camera and LiDARs, and your goal is to get the full picture. Remember when I was talking about a movie film? So see the car as you've got the director sitting in the car, he's filming the environment. And then when it brings it to the cloud, you have to do the editing. You need to find out what camera is looking at that. That's exactly in terms of the car. You have different cameras taking different type of information, data, sensors about weather, whatever. And your goal is to build a full picture, a full movie that you can give to someone to say, okay, this is the movie that you're looking for. And then once you build that, what happens then, you need to go and find out how are you going to use this movie to train a model. So training the model is just like a kid watching, I don't know, Rafael Nadal playing tennis. It's like, okay, this is how he hits the ball. This is what he does. That's what the machine learning model is doing. You're learning from the information that's there. And once you learn enough, have enough information, that model, then you take that model, you deploy it in the car. And then the car drives.
But who says to the model what to do in what moment? Do they imitate a real driver, or
Yeah,
I
yes,
don't know how...
you do. Yeah, you teach him. You teach the model. You don't tell him. You teach him. It's just like a kid going to school. He's learning.
You have an actual driver, a physical driver driving,
yeah.
and okay, and it's one one input, is one more input.
No, multiple inputs. As I mentioned, there's multiple inputs. So you can even see how the way the person drives, but most of the input comes from the sensors and the lidars, because what you're trying to do, you're doing perception. You want to find out what's going on when you drive the car. What's inside the car? Yeah, sometimes it's important to see again the driver behavior. Is the driver alert? Some car makers will take that information, but most of the information, it's outside the car, because when you think about the car, you're trying to avoid obstacle. The goal is not to hit, not to hit the person,
not to hit anything, not to hit.
So if I am getting this correctly, what you're saying, Gabs, is that there is a person who actually drives the car around the town, and then you build that into a model that then you give an autonomous car to replay that.
Correct.
Is that correct?
Correct.
I hope.
But as you optimize it, so maybe the first time it's someone driving, but the second time it's the model that's driving the car, until the model is optimized. So it's
okay,
a loop.
So basically what you're doing is, all right, this is your goal, and then train the model until it's able to replay the thing that the person has done.
Exactly. You're learning by example. This is how you do a corner case. This is how you stop at the traffic light, because the traffic light is red. So the camera will pick up the picture that the traffic light is red. Okay, I need to stop. So all that is recorded. So when you replay it to the model will say, okay, I've seen 10,000 traffic lights, and whenever it's red, it means I have to stop. So that's the difference to event handling, like you were asking that question, to actually learning. You're training the model. You're training it every single day. And to train the model, you have to have millions and millions and millions of recorded information.
And what happened with some situations, because if you think in, how's the film, Driving Miss Daisy, it will be a very nice car with a speed very smooth and everything, okay. But what happens when the thing is more complicated, is more complex? What does the machine model do in some situations where things are not so easy to solve?
Yeah, when it just stops, it doesn't know. I mean, you've seen some on the news, or there's been a car accident with an autonomous driving car, because they've never faced that situation. So they will think, okay, remember you're training a machine, you're not training a human being. So the machine, what you feed it, it's zeros and ones. it's like that picture looks like a horse, and after learning many times, they'll know, okay, that's a horse. For a kid, then you tell them that's a horse, that's it. They'll capture that information. But remember, you're training a machine.
But I think that using only images for this machine learning could be some kind. We would have some kind of problems, because you can see a horse and it could be an ad panel beside the road with a horse, and it's not a real horse. So
exactly. And that's why you have to see a lot of example of a horse. So sometimes they'll use millions of images just to know that that's a stop sign. Yeah. So how many stop signs are in the world? I mean, you go to Spain, there's a different type of stop.
There is a question in there, Gabs, and I think which Juanma is outlining. Is the car able to see in 3D? You know, to make a difference between as to say, all right, this is a picture, it's a flat picture of a car, of a horse, or it's actually a real horse which has some value.
So you have depth. So that's why you use all these different sensors. See that picture I'm sharing? So you've got LiDAR. LiDAR will give you that length, that depth viewing. You've got sensors, you've got cameras, and you need to have all this information to give you a complete picture of what you see. It's not just a 2D image, it's a 3D image with some wind or whatever. So these are really sophisticated devices that sit on top of the car. And as I say, you capture all this information, you put it in the cloud, and that will build you that full picture of a drive scene or drive scenario.
Gaps, one moment.
Why it's so important, why it goes in the cloud is big data. It's a lot of data. We're talking what petabytes.
We need to stop here because we have to stop in the 40 minutes time. Okay. And reconnect again. This is the usual way that things go.
Okay.
See you now.
Connect now. See you.
Okay, go on, Gaps. Thank you. I'm sorry for stopping you.
Let me get the camera on as well. 1 second. Once I know, start video. Okay. Great. So as I was saying, this is the starting point for autonomous driving. Your cameras, your sensors, your LiDARs. This is what it's filming the real world, and is using that film to train the model. And in between, there's a lot of services, data processing, simulation, DevOps, machine learning ops, and you'll see in the reference architecture. But all the car makers have these on their car. Some have different models. There's a company like Intel, they provide these sensors. There's a company, Sony even provides some of these sensors and cameras. There's other manufacturers that do that.
Do they share the data?
Sorry?
Do they share the data between companies? Because I mean, this is
some do, because it's a very expensive
huge amount of data.
Yeah, it's very expensive.
And unless they actually share the companies, you may end up with cars that are better than others and more dangerous than others. You know, kind of. If they share,
that's a good point. That's a good point, because it's a very expensive business developing this autonomous driving car. You have to put a lot of investment and data. Data to move data from one place to the others. So inside the cars, you'll have, what you call data loggers. So the data loggers is connected to the sensors, the cameras. So whenever it's just like remember we used to have those, instead of our phone, you used to have the camera recorder with a VSS tape, same thing. So you record, it's saved on the tape, you take the tape, you ship it to Microsoft. Exactly the same way that, again, we used to do with our VHS recorders. That tells us a bit about our age. So a lot of data, and very few car makers throw away the data, because sometimes the reason why they don't throw away the data, because it's when the car is ready to go into production, you go into the city. Let's say there's a problem with the machine learning model. The first thing a government will ask you is like, okay, how did you train your model? Where's the data that you use? So car vendors, for them, this is very important for them to say, okay, this is the data set that I use to train my model. Traceability of the data set, because it follows the optimization of the machine learning model. So the more data you give to the model, the more precise is it. But at the same time, if there's a car crash by an autonomous driving car, how do you trace it back to say, okay, what data did you use to train the car? And if you don't have that information, then you're in trouble.
I think
all this thing that you need to look after.
I think it's off limits for this podcast, but it will be interesting to know what the legislation, the regulations are for that kind of thing. If your model was wrong, you are.
I was about to ask about that.
Yes, but I think it's not relevant for the actual podcast. There is so many things that are interesting that regulation is not one of them. I'm interested.
Regulations have to happen, because you cannot deploy any car there without a regulation. Even today's cars, there's certain crash simulation specification before they let you produce a normal car with a driver. So same thing for autonomous driving. There are some regulations. Some countries are more advanced than others, but you need to, because you essentially have a computer on wheels that can do whatever you want. people can, a computer, it can be connected as well. So if it's connected, someone can hack into it. So all these things you need to look, I mean, keep an eye on it. It's not just
but I mean, for the sense of what we do here, are doing here, I think it's more interesting because we are no lawyers, you know. and I think it's more interesting to know the technology, you know, what are the amount of sensors they are there, the amount, I mean, or the controllers and how they are the development practices, because, you know, you need to be very careful about these. How do you audit that they are doing the thing? If you do code reviews, how you guys make sure the quality control of this thing is at level. I mean, I think we could be years talking about this.
It's a mission critical device you're designing, and it's software based. Nowadays, there's more engineers, software engineers in the car industry than mechanical engineers, because everything is computerized. You will go and look at the press. They're hiring software engineers now, not mechanical engineers, to build all the functionality in cars. Infotainment, so you have your car, your dashboard, you need to have video, you want to have streaming, you'll get someone to run, I don't know, a small Linux platform that will do digital media, for instance.
They're not using Agile.
So this is, again, yes, this picture here, this picture is trying to detail all the steps that you need to essentially be successful in building an autonomous driving car. So a lot of features. What's happening in the car? So in car, you have perception, car planning, vehicle motion control. All these are interlinked. Then car in the car, how do you provision this car? How do you connect to the car? So today, what you have, there's actually, I mean, there's another team in Microsoft and also in the industry. So you've got the connected car, which is just today's cars, and you have the autonomous driving cars. But then you'll have the connected autonomous driving car, which means that the car has like a 5G and is connecting to a data center, is sending information. So today you have Renault, Volkswagen, they have them in their car, BMW, they have that in their car. So the car, instead of you checking, okay, or it's time to change all the maintenance, the car will connect to the dealership, to where the car garage, and say, oh, well, you need to book me in on certain date for you to come and check my oil or whatever. Connected car. So this happens today. I mean, in most of the newer car they build, you have connectivity. So it's like a computer on wheels that you monitor. So Guillermo, all the work that you were working on Tivoli, remote access, and that's essentially what's happening today.
But Gaps, what are they planning to do with that final step 5 for the level 5? No, you said autonomous driving level 5. They will relay on the communications, or will be the car completely autonomous?
They have to. They have to. The reason behind that because you need things like maps, satellite.
Yes.
You need to have weather condition. So there's other variables that come into play. It's not just the car that autonomous. The car needs external information. The car needs to know that, for instance, that it's raining if they drive for 10 kilometers, it's going to be rain there. So I mean, just give them enough information to know what to do once they get to that situation. So all the cars in the future will be connected. That's a given.
Wow. No, but so basically, what you are saying, it makes a lot of sense. So it's so much information and so much decision making behind it, so much computing power that you need that it doesn't fit in a car. But that creates a very dangerous precedent for security. I could know in which car you are, and I want to get rid of you, and I could actually hack into your car and cause a crash.
As I say, it's a computer on wheels.
Or hack the car of somebody else to crash against you and kill you.
Of course. All these topics have been discussed, but again, that's why it's so important to, when you build it with security on mind.
No, but
it's not an afterthought.
It's not only with the autonomous car, it's also with a connected car.
Yeah. Any cars. It's just like your computer. If you don't connect to the internet, you just have it at home, no one's going to hack you. Same concept.
That's
Exactly
what
the
happened
same.
to my Spectrum. Nobody can hack
As
it.
far as I know, well, actually, the company I work for does actually connected cards. We're one of the providers of the embedded SIM that are on the Volvos, on the Mercedes, and some German cars. The challenge with the connected cars, it's that thing, okay, as well. That it is not only that it is hard to have all that computational power isolated on the car, but also that you need the proper network deployed along all the roads that automated car, autonomous, sorry, car, it's going to pass through. Today, we are all speaking about the 5G and edge computing, blah, blah, blah. I've been for, well, not the last 2 years, okay, but the previous 3 years has been going to the Mobile World Congress in Barcelona. 5G has been a big topic for 5 years now, from my own point of view, okay? And I don't think that's still nothing but a proof of concepts regarding the kind of connectivity technology you really need to have a good autonomous car experience.
Right.
So I don't know, Gaps, from your perspective, if the challenge is more on the car itself and the sensors and the artificial intelligence, or
Yeah.
is it more on the connectivity?
Yeah,
I think
you're
I
right.
think it's-
Latency will run also. You may have a
Yeah.
problem. Is all decision making is happening. If the system have a high latency, the answer could come late.
Yeah,
Yeah.
but yeah, I'll answer that question. There's twofold. So there's a connectivity, as you mentioned, is critical. So you need to have enough bandwidth, enough latency to communicate between, I don't know, your data center and the car, how you manage it, how during the duration of the car, how you react to events that will come through over the network. That's one thing. The other thing, in terms of the car itself, the autonomous car, ideally, I mean, what all the car makers are doing is they build enough compute power that all the maneuver and the decision are processed inside the car. You don't need to go outside to process it. So some of these cars, I mean, they're honestly having supercomputers running in these cars. You will hear in the press, high performance computing, autonomous driving cars. So essentially you have multi-node, high availability. You'll have maybe the equivalent of 4 or 5 servers running inside the car. So if one fails, the other one take over. Because it's critical. I mean, think about it. I mean, you drive a car.
They will be more like an spaceship.
Yeah, it's a mini data center.
But
you have a data center.
There is one point that Felix point out there, which is very important. It doesn't matter really, Gaps, because it doesn't matter if the car is a Cray 1 or Cray 25. You know, the problem is that the data it needs, it may take too long in arriving.
Yeah, but it depends
it may be late.
I agree. But what I'm meaning in terms
the data it needs to process, because it may not have it right now in the car.
That's what I'm trying to explain to you.
That's a different problem.
Yeah,
to get the data it needs for their decision making.
Yeah, no, but you don't need the data you don't need outside data to process the information, because you've trained the model, you've given them. That's why it's taking so much time, because what they're saying to you is like, for you to have external data to make a decision is too slow. There's a kid who's crossing road is in front of you. You're not going to go to the cloud, come back to make a decision. You have to make that decision in sub-milliseconds inside the car. That's why you spend a lot of money, a lot of time training it, a lot of data.
Good.
So having an outside dependency, it's dangerous. And again, unless you, I don't know, you have a dedicated pipe between the car and the data center to say, I'm going to give a QoS between the data center and my car to say that I have enough round trip to make a decision. Yes, but that's not the case.
Okay. Help me please, Gav, maybe to demystify some of the bias that I have regarding the autonomous car then. From the connectivity point of view, everything that I have listened to, even internally, my colleagues in so is that the future that we're aiming for is that the cars will be talking themselves, each other, and the car will be talking with the road and with the semaphore, and that's why having 5G is that important. So
Yes.
it is not only that the computational power that I perceive, which is digesting a tremendous number of data collected by the car itself from all the sensors, okay, that it have. I can see that that can have a solution by having a data center inside of the car. The thing is, or the challenging stuff here is that the rest of the components for an autonomous car to communicate with needs to do in a very specific conditions, and that needs to happen regardless you are on the field, in a city, or whatever. Otherwise, the car won't be able to bring you there. And
yeah,
that's
I know. I mean, and you're correct.
what's wrong,
You're
okay,
correct.
in my perception today.
No, you're correct. So there's two angles. One angle is, again, I'm going to have a car. It's not that I don't care what's going on in the environment, but I'm going to try to drive without any help from outside devices or whatever. But there's other thing, as you described, the whole city is an IoT device, the whole city. Billboards, everything, it's giving information to the car to say, okay, and other cars will have, again, they'll probably have their private network between cars to say, okay, I'm here, ping me, to that level. But right now, what people are developing is to have an autonomous car without the need of speaking to my neighbor. But yeah, there are people doing research to say that, let's say you have a fleet of cars that drive the road. Ideally, just like, I mean, ants, they all go the same way. They use a pattern. I'm sure you've seen those videos where they're like on a train. They're driving, I don't know, 100 kilometers. Instead of these cars driving and overtaking, you're all part of like a train wagon. They all connect and they all speak together and say, okay, let's just drive to our destination, just specifically just lining ourselves like we are lining in, I don't know, like those train wagons, the same way. So this development is going on right now. But the area where I work is the focus is on the car itself. The car can drive itself regardless of the situation. But of course, I mean, having external input is very important.
I'm very biased by the connectivity challenges, okay, and wasn't actually aware.
No, but you are right, Felix, because it's huge. So we are talking about, more importantly, the communications. You know, I never thought about what you were saying there. You know, which is when thinking about the countless hours I have spoken with Gabs about this. You know, the fact that what you're saying, I mean, if something is coming down the road and it's not in my data center, you know, I need to find it from somewhere. And that information, I mean, I'm sorry, Gabs, it's impossible that car have everything, all the information in it.
Of course, but your goal is to train it to have as much as possible.
No, but maybe by the time this will happen, because one of the things I'm identifying here is the fact that we need a federation system in order to identify each device to each other. You know, in the case, because I could hack a device and say, all right, the traffic light is open but it's closed, and then the car crashes and kill you, you know, right? So we need, you know,
you need to think for this. You need to think
a huge system just to make sure that you have the right to talk to me. Not the ability, but the right.
I think we spoke very little when I met you in Seville, Gabs, about the over or side the road systems. You will need some kind of digital signaling. You cannot trust in a signal that tells you to stop, because I can draw a signal like that and put it in the highway, and I will get all the cars stopped.
Yeah,
okay. You cannot
do that. There's stories about that. Someone drawing a sign on top of a sign, and the car looking at it and then not recognizing it. No. So all these are edge cases. I mean,
there was an history.
The more the car sees this thing, the more he can react. But if he's never seen it, then it's like, okay, what do I do now?
You will need, I think that the driving will need to get the approach as flying a plane. And they will need digital signaling for getting in which street is which city, if the street is two ways, only one way, or if there is some kind of work operating in the street and it's closed. And then
and that takes time and investment. Not all the cities, because certain parts of a city might have it, but whatever you step out of a big city, how do you react? So you have to do, it's a lot of investment. When you think about it, you're driving from one city to another. One city might have all these fancy IoT devices that can speak to the car, that can tell it, say, I'm here, I am a traffic light, I'm not a bicycle. That's very expensive. So that's why car makers are saying, okay, for the ideal world will be a whole connected world. Everything has an IP address and a MAC address, and you can speak to it every single day. It can tell you who I am. Digitally.
So if
that's not possible. We know that.
If we are driving level 3 cars, I think that level 3 is driving assistance. I suppose, like the changing lanes and stopping. What is level 4? Because level 5, we can imagine level 5 because we have seen out of films.
Level 4 is hands off, so you don't need your hand. Level 5 is mind off. I don't care.
Okay, very good. Very good definition. So hands off.
This is not my definition, but it's that what the industry tells us about.
Take me back home from the bar.
Yes, but you still have
drank too much. I cannot even think. Just take me from A to B. That's it.
Or you are coming back from the bar Jota and they say, take me home.
And now you're seeing some cars that have been designed without wheels. Those are level 4.5 cars. There's no steering wheel.
But you mentioned something interesting. You say that this is going to be extremely expensive. Is it worth building?
Is it? How many people have been saved by how many people die from car accident?
I think that the final model will be that you will not own your car.
No,
the car will be a furniture in the city. So the car has to be very autonomous and very connected, very well connected, because you won't need a car of yourself.
And you see a lot of the companies like the rideshare, Uber was investing, but then they stopped. So in the US, most of the development is done by these ride sharing companies. Lyft is one of them. In Las Vegas, I was there 2 years ago. You get off the airport, you call a Lyft, all autonomous. It takes you to your hotel. The reason it's easy because Las Vegas is like long roads. There's not many old buildings. It's much easier. There's less complexity.
And it's across the road from the airport.
No rules.
It's across the road from the airport.
There are rules, but it's there. I mean, you go to Arizona as well. So there's a lot of places in the US. They are fasting forward the development of these cars and deploying it.
But Arizona, I love Arizona. I love Tucson. I've been many times in Tucson, but Tucson is very easy. If you get lost in Tucson, it's to kill you. I mean, it's you get a big mountain in the north, a desert in the south, and all the lanes are straight. There is no.
Let me quickly jump on this. This is more again what I do in terms of the reference architecture. These are all the blocks that you need to test these cars. So you'll see on the left, the car itself, you collect that data. And that data is so big that, you can send it over the wire, over network, but it will take you days, but it's going to be very expensive. So we have two options. You can go, you'll see data box. So this is like it's like a big USB stick. So we're talking about petabytes of data that the car owner, the test driver will, the recording data that comes from that gadget, you copy it onto that data box. It's like a PC and you have a USB interface, you connect to it, you copy the data and you lift that data and you ship it to the Microsoft data center. And that goes into data ops environment. And that's where we bring all the different services. Okay, what's this data? What part of this data do I need? Do I need only 20%, 50%, 80%? So that's where you do data transformation. So you get recording. I mean, recording takes a lot of space. There's some recording you don't need. I mean, if you go on the same road 5 times, some of the information is not interesting. It's like, okay, I only need to record it once. The only thing that's really important is an event, someone crossing the road, a traffic light going from red to orange. So it's an event that's happening, but just normal blue skies, the sun, all that information, I just need to record it once. So that's where that area in terms of data ops, that's where you're basically deciding, okay, what are the interesting cases? And why they spend a lot of time there, because it allows you to really narrow down a specific topic. Like let's say you want to find out how the car behaves when you do left turns. So in that data, you only want to see, like an engineer want to see all the recording over the last 2 weeks about left turns. So you search it the same way you search a database, but you're searching basically through video. So it's very compute intensive. I mean, you need to have a lot of compute power to find out, again, of these 10,000 video files. And some of these video files are, again, 20 minutes. But what they do, they chop it into smaller chunks, like 4 gig chunks. So you just check in this first 4 gig chunk and you get a data stamp on that 4 gig chunk. Is there a corner case? Does the car turn in that 4 gig? No, it doesn't. Okay, I'm going to move to the next 4 gig. You've got 10 petabytes. So you have to sift through all of that data. And the reason it's compute intensive, because you want to have that information as quickly as possible. So that's why you bring the scale. Yeah. So each machine, you'll have a single GPU. All they're looking for corner cases in a 4 gig file. A simple process is like, I've got data, show me where in that movie, where can I find corner cases? And you do it 10,000 times. So it's a distributed use case, loosely coupled. There's no dependency between the processes. So you get one process will run on one GPU, another process will run on the other GPU. Once you find the corner case, you save the data onto your storage, your blob storage. And then you have, again, and once you save that data, you can create a metadata. You can create what they call a scenario database. And that scenario database, it's for allowing the engineer to say, okay, show me in the last 3 weeks all the corner cases. So you get metadata, data, search. Once that information is available, then once you have that information, you can use that to go and train the model to say, okay, hello, machine learning model, this is all the turn left cases. Learn how a driver turned left. And the machine learning will learn that. You'll see multiple ways. It's only turn left. That's all he knows. Okay, this is how. So, and that's just one use case. So there's turn left, then there's traffic lights, then there's pedestrian crossing, multiple different scenarios, how a pedestrian cross. So it's very compute intensive. You have to run a lot of simulation, parallel simulation, no dependency, but you do it multiple times across multiple machines.
When we were doing the parallel systems that we did for the University of Edinburgh, one of the things I learned there was the fact that there is a lot of points of failure in a system like this, and then your process needs to build a pattern that will allow you to actually reduce the amount of points of failure. And this is a
point
massive
of failure. Where exactly on
point of failure? For example, you don't have connectivity, or for example, the power is gone in the tower, and then you don't have access to certain data. I don't know. Imagine
that's why before you
if
do
you
your
have a
processing,
pipeline, in the moment, if the pipeline is just sequential, the stage, if you are stopped in stage 3, you cannot get to the stage 9, and that kind of thing.
That's why the data is timestamped. So as the data is coming in, you process it. If there's something missing in that data, you can throw it away and say, this is not interesting.
Basically, something that may refrain the car from taking making a decision, like, for example, imagine, if the sensor of the rain goes off.
It's not just one event. That's the thing.
No, this is what I mean. You have a huge amount.
Yeah.
You have a huge amount of point of failure.
You have maybe 10% of what they call bad data. As you mentioned, the camera, suddenly there's a problem. I don't know, a bird hits the camera, it doesn't record something properly. But if you've done it across, I don't know, 20 hours a day with 20 cars, So you reduce the level of errors in your that's why I mean it's very
my
very
problem. My problem is the same as Felix, you know, but it's just, is that Felix is obsessed with the connectivity, you know, and my problem is that you know that for 30 years of my life I have spent making sure the computers don't fry themselves, you know what I mean?
Yeah.
So I have the same problem
that's
with
why
this,
machine learning changes that. That's why we're moving away from
I just seen points of where things may not work.
Yeah, we is a good example I can explain to this is like mean time to failure of hard disks. Nowadays, before, remember when you buy this hard disk, they'll say, okay, on average, after X hours, it will fail. Now a computer will make that decision for you through predictive maintenance. Because it's been used for X amount of hours, I know it will reach a point that it's going to fail. And I'm going to tell you, the machine learning model will tell you that it's going to fail. So you don't need to just listen to the manufacturer that says, okay, after 10,000 hours, your disk drive is going to fail. So the same thing with machine learning and deep learning, you're trying to predict the future. You're trying to predict based on the past, on what you know, on what you've seen, what you've learned. That's the difference. You simulate on one side, the other side, you train and you learn.
Perhaps when I'm not machine learning specialist or nothing similar, I have read a few articles and listened a few podcasts and things like that. There is a problem in some other machine learning use cases called overtraining. When you use a lot of information for training a machine, you can incur in an error called overtraining, that is that the machine only distinguish what you have trained the machine for and not any other things general, let's say. Is in these cases, is the better the best? Or
yeah, there is a risk, but to avoid that risk is the variety of the data. If you have a more varied data, more complex data that comes from, let's say you train your model in Seville, the car only drive in Seville. So it will only know about Seville. So if there's something wrong with that model, you take that model, you say, okay, drive the car in Barcelona. It's like, what you tell me? I don't know Barcelona. You've never showed me how Barcelona looks like.
It's like me. It's like me.
Honestly, remember in IT, we said garbage in, garbage out. It's the same thing. Whatever data you give it, that's what you're going to train it for. So the more you train it with different models, different types of data, the more intelligent it's going to be. So it's a computer. It's dumb. People don't realize computers are dumb. People talk about AI, rubbish. Whatever you feed it, the input, it'll use the input to divide the output. It's the same thing with machine learning. People think, oh, machine learning is this clever thing that, no, it's not. It's, you have to feed it something for them to learn.
There is a very, very interesting case I heard in one of the meetings I went in Seville about artificial intelligence and machine learning. I think that it was the US Army. They were trying some kind of device or another device with some images to distinguish a tank inside a forest. And they trained the machine. The machine went optimized, always guessing with the training images where was a tank and where there wasn't a tank. When they went to the field, the machine didn't set one of the choices right. Because they took all the images with tanks in a cloudy day. And all the images without tank in a sunny
it's just
day.
Like IDs.
So the machine was telling you when was a cloudy day on a sunny day. No, there is a tank.
There was things again more to do with my color.
It's not the right color.
A lot of machine learning models that cannot pick up my color because they have been trained with people look like, I don't know, like Guillermo, not like me. So whatever is, again, data is more even important than the model itself, because the model is just following what the data where the data come from.
The variety of the data, no?
Yeah,
Yep.
but one
One question here, Gabs.
Okay.
Thank you. On a previous slide, well, we have been talking here about, I have here the words machine learning, but then on a previous slide, I read about neural networks. And I'm actually wondering if the kind of artificial intelligence techniques that are more related with training the autonomous car, it's more neural networks, genetic algorithms, machine learnings, all of them, depending on the stage of that.
Yeah.
Mhm.
It
So
can be machine learning, it can be deep learning, it can be training, it can be inference. So inference is basically you're trying to infer. You're not getting trained. You're trying to guess what's in front of you.
next. Mhm.
Yeah. So yeah, it's whatever tool that is needed to detect, again, object classification. You've got different objects. I need to pick the right object for what I see. That requires training. In inference as well, they can be you can do infer. You say something, it looks like a horse, it's a donkey, maybe not, it's a camel. You're trying to infer, you're trying to make a educated guess.
But then who selects the best technique to apply for classifying each stuff?
It depends. It depends. Some of it, yeah, you just need, again, a lot of images to do, I don't know, to use deep learning techniques. It really depends. If you're doing object classification, then yeah, deep learning so far has proven to be the most precise way of doing it. If you're using things that are less complex, there's less ambiguity, you'll do inference. You don't need a GPU, you'll use, I don't know, an FPGA, for instance, because you know that the way you program your FPGA is just going to look at these things. So that's why the cloud is so important. I mean, again, this is not a marketing thing, but it's because of the cloud, you can have multiple different devices. When you have your data center, again, most customers, they'll go and buy, for the worst case scenario, they'll buy 10,000 GPUs of this model. The cloud, you can hire different types for your problem, you can solve it many different ways. Sometimes you can solve the same problem with different cards. You can use a GPU from NVIDIA, or you can use an FPGA from Intel to solve the same problem. The goal is to reduce the time and the cost of running your simulation. All this is about simulation. And when we speak to customers, they say, okay, what is the price of your simulation? Because it's not the price of the device, but if the simulation is 3 minutes, but it costs you, I don't know, $10,000, then yeah, you need to look at how do I optimize it.
But then do not get me wrong, please, okay? But it's like the technique to use to classify, predict, whatever the actions, okay, of the artificial intelligence. The specific technique to use, it's driven by the decision of the engineers, mostly based on the status of the art of the artificial intelligence nowadays, but it is not determined by testing one technique, one each other, but more on what the engineers believe or propose. I don't know if you see my point here.
You mean comparing different kinds of techniques?
I think what Felix means.
My question is exactly who is deciding which technique
I think that it's more of like, if they are the engineers designing the system, is there a data scientist deciding who defines the learning algorithm? That's what.
Yeah, exactly. So a few years ago, it was the engineers. Now we've got something called AutoML. It will decide, okay, what technique, what statistical technique do I need to find my results based on the problem that is facing. So to your answer to your question, yeah, today is engineers that based on good data scientists, good statistician who know, okay, for this problem, I need to. Yeah,
No,
I said, yeah, that was a very good question, Felix, about, yeah, who make the decision about what tool to use to resolve the challenge, the problem, so nowadays, again, development around auto, they call it AutoML. When you search, basically it uses, again, techniques that previously it will be a data scientist who will make that decision, or I need to use this statistical model to find the answer. Instead of doing that, now a model will decide on how they solve the problem.
So basically, you're saying
it's scary.
basically you're saying that the machine learning is deciding itself how to learn.
No, not how to learn.
Recommending
which technique to learn, to use. You're still teaching him, giving him data, but then within when you do machine learning or deep learning, there's different types of, let's say, classification, for instance. So if you do statistics, then you will say again, which is the best method to find my answer? And there's multiple different techniques to use. But the model is driven by the data. So if you don't have any data, so you won't have the full picture.
Mm-hmm.
It's a complex field. I mean, yeah, I've done some statistics at university, but that's useless. You need to apply software engineering. You need to apply today's technology, neural networks, deep learning techniques.
And
but all these, I mean, these are just components, but you need to build, for you to build a full picture.
Amazing thing.
Yeah, it's, so sometimes I'll speak to customers, all I care about is, how do I scale your machine learning model? I don't know. I mean, I don't open this Python script to say, okay, this is how you make the decision. I'm not interested in that. I'm at the infrastructure level. I'm saying to that person, that data scientist, yeah, give me your model, give me your data inputs. I can scale it 1,000 times because I have tools that allows me to pick that script that you're running on your laptop. It's a single script that bringing some data, individual data, but I can do things like parameter sweep across multiple machines, collect the rate, the information, because you have to do that at scale.
I think right now it's out of order, but someday you need to explain to us the tool chain.
Yeah, we'll go into detail. Yeah, the tool
yes,
chain.
We could have another chapter.
We need a specific session on the tool chain.
Tool
chains
and the topic of the digital twins. I think that it could be very interesting. Maybe we are out of time, especially for you that are 2 hours ahead, and so it's very late there.
No, it's okay.
Yes. One last question, without revealing any industry secret.
Okay.
Which is the roadmap? Which is the plan of the companies? What we have this, what we said, this level 3, almost level 4, some experiences with level 5, but what they are thinking, what time do they think they will have a real car for renting, for example? I think that will be rented, no.
Yeah, again, it's back to the level. So level 3, I would say in the next probably year and a half, you'll see level 3 cars in a year and a half. Level 4, maybe 2-3 years. Some companies says, I'm not going to name them, you know them. They say, no, they already have level 5, and so there's a famous company, we start with a T. I'm sure you heard about them. Say they have fully autonomous cars, but yeah, that's what they say. For us as Microsoft, well, hey, I'm speaking for myself. This is my personal view, but it will take time, and regulation will slow the adoption of these cars. Some cars are ready.
Do you think that regulation will be the big problem here, not the technical?
Yeah, it's normal when you think about it. I mean, you're releasing people can turn a car into a weapon. If you think the worst case scenario, someone hijack a car and do something, but at the same time, the car, if it's well designed, again, well trained, it's saving people's lives as well.
And they will need a special insurance. Car insurance, no? Because they will need.
So insurance companies are starting to think again, are they going to make money? Because if all these cars are so safe that there is no accident, then how are they going to make money? How are they going to put premium on more money on your premium?
I'm actually thinking in a business where I'm going to hack cars and send it to hotels. You know, which hotel is going to pay me more if I send the guy over there? He's going to hotel Melia, all right, I take him to the.
It's just today's world. I mean, we know cybersecurity is big business, so the same way you design a car, you need to think about, again, what are the effects of all these things.
Well, the problem is that, you know, I think the real problem we have in here is that what we are talking about is a very, very, very extremely complex thing, you know, and we all here are trying to think about a way to make it real.
Yeah.
and you know, and it's so huge, you know, as I said, because my background, I tend to think this is gonna fail here, this is gonna fail here, this is gonna fail, you know. This is the problem with engineering.
That's the same.
It's my fault. It's my fault. It's my fault.
No, that's the same way you train the model to say you train them for the worst case scenarios. That's going to be the most precise model.
To be honest, I never thought it was so big.
No, it's huge. It's a big business, and only few car makers is, the big companies in this world.
They need to share the data, as Felix says. They're
starting.
Talk to each other.
It's important. They're starting. The reason why they're sharing, because it's just too expensive for everyone to collect the same. When you think about it, you collect the same data in the city. You drive in Dubai, in Barcelona, in Seville, wherever. It's the same buildings. The only difference is during the day what happens. Someone crossing the road, but the data is the same.
Something I am thinking. Sorry, Felix, please.
Actually, there's one thing that all the governments can do good for us, and it's making mandatory that all those data used for training those models, all of those should be open data or public domain for the sake of the next research to find the next stuff. So if you are going to do some autonomous car, please know that all that money you have spent in grabbing data, that data will be open data. If you're the first one to use that data for your own business, try to get the most of it, okay? But please know that data will be open eventually. That's a good demand, okay, that we can bring to the...
well, the problem is they will say,
what's happening,
that's
a very good point. What's happening, because they realize that there's so much data. Now, there's some companies that are building virtual world, synthetic data to train the car. So there's some companies today, I mean, some of our partners of Microsoft that are building whole virtual cities.
One question for our listeners, if you want to call it that way. Could we open a kind of a startup by doing driving, and obviously we're not going to send Juanma to Barcelona, but you know, recording and then selling it to Microsoft?
Some insurance companies is offering today that to you in Spain. I mean,
I have another idea. I have another idea.
In your car, okay?
Why the artificial intelligence or the machine in the car or in the cloud should be part of the car maker? It should be some external companies, as they sell you any other piece of the car, they could sell you the intelligence of the car. It could be another piece.
Well,
not done. But sorry,
you know, competition.
It's called Microsoft Marketplace.
You know why? Marketplace. You know why? No, that's the point. You know why? Because you don't drive the same in Rome than in Huelva, where I was born. So you will need a special intelligence for Rome and different one for London or for Glasgow or for any other Dubai. Or for
when they test their vehicle, they test it in all the cities. Some of my projects that are global. You can test in Asia, test in Europe, test in the US, the same car. But the data they collect, it's specific to that region.
They
train the model.
Do some fine tuning.
Yeah, that's a good idea. If you keep the cars in a certain location, like they will get more and more data, they will become better and better. But if you take them to a different place, you know, you could take the brain and put it somewhere else, you know, especially if the brain is not in the car.
So today, Tesla in their cars, it collects data while you're driving your car. So it's not a test vehicle, it's a vehicle.
I have a question about Tesla.
Well, again.
No, it's true that
I know nothing about techniques. That's all I know.
All right, no, but it must be told. it's true that someone actually made a Tesla crash by painting something in a wall.
Well, that's what they say on the internet. I'm not sure I cannot say this is true or not.
Yeah,
But
no, because I hear that the someone actually simulate a street or something.
I've read it somewhere, but again,
you know that this is called the
everything you read in the internet sometimes is true, sometimes it's false. I don't know. I'm not lawyer.
Yeah, I read that Juanma is very good in driving out of Barcelona. But...
This is called the adversary attack, right? Yeah, where you can paint some kind of graphics. You know that camera that recognize people, and you can wear a T-shirt with a special design, and the camera will not recognize you as a person, because this is designed to confuse the yes. So
these are the extreme cases, the worst cases.
That T-shirt.
This is that T-shirt.
This is the T-shirt. For you, okay? Please buy my T-shirt, okay?
No, that's nice. I'm gonna buy one. The thing is that, you know, the point is that now the techniques of the coyote, you know, with the road runner, you know, are working. Paint here. You know,
it's the future. I mean, we cannot fight against progress, but I think we need to go safely.
But the way you describe it is such an amount of things that need to get together in order for it to work.
Of course.
But there is another point of view of all this, because of course the cloud will be and is today is already will be more important in our lives.
Connectivity, as Felix says.
Connectivity is the second point, and
maybe the first.
Well, okay, the first, because you don't have connectivity, you won't reach the cloud. Okay, but there is another issue with all these embedded systems that will be on board the car. We now have a crisis with all the semiconductors. We are doing this, and we hope to have all this kind of sensor, radars, lasers, everything. This is a huge amount of resources. I don't know if we are going to solve that. We are going to need to we are going to travel to the moon to get the selenium. Or
man, do you remember when you were in Greenock in the IBM plant, and Gabs was there and I was there at the time? We were already, that was about 2000, probably 2001. And there we were actually playing with something Gabs will remember called millipede. There was a kind of actual organic, you know, mesh that was able to store gigabytes of data. And we're talking about 2001. You could actually paint a wall in your data center that will be your storage with that millipede. So all you have to do is paint the car, paint the things, you know. I'm sure that thing is 20 years ago. So, you know, there must be an advance on that. It will be maybe 10 times more profound, the amount of data you can actually more deep, you know, that you can put more data on it, and you can paint, you know, you know, you can paint the car, and then you may have space for
this
petabytes.
This means that we will need another revolution, a digital revolution with other kind of biochips or
no, but by the time these cars will be ready, because I don't agree with what Tesla's saying that in 5 years they're going to be in level 5. I don't think so. I think because you need to get a lot of people to agree. You know, I think that the problem you have in this is not actually the technology, but the social, you know, aspect of it, the regulations, all right, you need to share your data with me, otherwise we may have a problem of compatibility. That will be a very big problem as well. The fact that there is industry standards need to be decided, they need to be made, you know, they need to be nurtured in the sense of, you know, otherwise people may play game. It's like crypto, the same thing, you know. You need to get rules apply to it, and then a lot
There's
of people
rules
play
and-
with crypto.
Yeah, you cannot design it in isolation. You're in a society. There's how society functions. There's banking
As you said,
systems. There's
you
all these
said
things.
that will slow down. The regulation will slow down the development of this.
Yep.
So I don't
Well,
agree
for
that
good
in 5
reason.
years.
It's-
So I'm sure.
Yeah, but we cannot just design something for the sake of technology. We need to make sure that it's safe,
No, but-
like any other things.
But this is being built for the day of tomorrow, not for the world of today. That's for the world of tomorrow. And I'm sure that by the time this thing goes out, cars will be able to, store like zettabytes, exabytes,
Yeah,
of
course.
data.
Yeah.
And there is another thing, not only the technology and the regulations. We have people, and people right now, I think most of them are not used to manage of this technology. You can drive a car, but you are not able to keep your secrets, your digital secrets, your key, your digital, digital coins.
Your
People
footprints,
are currency, yeah, right. They are not accustomed. They are not used to that, to all this technology. How are you going to teach them that a car is a computer, a very complex computer?
You're talking about people of our generations, but the people is going to be using this is generations away.
Yeah, generations. Okay, yes, that's right.
They are not going to need to learn that. They know that since they are born. They're be connected. My daughter is born in a connected world, and so for her, when I explained to her that we used not to have internet, that is something that it was made
Don't
like
do
10
that.
years before she was born.
Don't do that.
Just like,
Poor her.
you
Poor
didn't
her.
have,
robotic modems.
you didn't have Google. How
This
do
is
you
good.
how do you end arguments? Well, the way a man finish an argument. Yes, darling. And this is the thing. I think this is something that is going to go in the future. And by the time this thing is released, I'm sure that the cars will be ready to process all that information. I mean, a car is big. And if you think about it, they will be electric, and all the space they are now having for an engine, it will be a computer, because an engine for an electrical car is something like this size, and then the battery can be in the floor, so all the space it can be used for storage.
Of change of computing. I mean, I can give you a really good example. When I was at IBM, when we designed one of the first,
but the energy
Shell.
consumption will be a challenge.
Yeah. The first, I can give you an example. The first project I worked on in IBM on high performance was at Shell, and they had 1,000 machines.
I remember. I helped you build some of them.
Pentium 3, 1 gigahertz. So that whole machine, 1,000 machine, is 1 teraflop. So today in a GPU, you have 1 teraflop.
Yeah, but
one GPU card.
I still have a
1,000
picture.
machine. That was 20 years ago.
I still have a picture with that machine that you guys built, and actually you haven't said the whole history with that machine that Bagams and David McLaughlin and all these guys built. That machine actually found the impact of a meteorite in the channel.
Oh, really? I didn't know that.
You didn't know that? Yeah, no. They actually found that the separation of the British Island was that made with that seabed exploration with that computer.
It's called Genesis, that machine.
Genesis, yeah, remember. What was the name of the guy in the States, the guy from Salt Lake?
Egan Ford.
Egan Ford, yeah, remember that. I still have a picture.
And I remember you wrote Asma card.
The firmware for the server,
yeah.
Yeah, the service processor code that will manage the computer even when it was off. Science fiction.
Out of bank management.
Yeah, remember, I did the code. It's a service processor. It's a card that you could manage the computer when the computer was off. You were able to configure it remotely. And remember that you did a BIOS simulation we were going to put in them. So you could actually simulate the BIOS for the customers. Remember you did, Juanma?
Yeah.
You did a BIOS simulation?
In JavaScript.
Well, whatever. So you invented JavaScript.
Well,
No, but this is amazing. Absolutely amazing. This is close to what you do, no, Felix?
I'm most on connectivity, SIMs, UICCs, embedded connectivity.
mm, mm.
I don't know if that's related.
Very
I
related.
I really like what I do, okay, but it's not that related, I think.
No, well, all the communications between the different elements of this thing, if you look at that thing, all the lines involve communications, connectivity. You know,
For sure.
I think
But my expertise is doing the applications running
All
inside.
right.
inside
Okay.
the sims. They run inside the sims.
Exactly.
They run inside.
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 You have to listen to the
embedded software.
chapter about
I
the
need to. I have to. I have to. I have to. I have to.
SIM cards. It's amazing what you have in there. So guys, I think that it could be time to close the episode, this chapter.
Thank you.
It's really amazing, Gabs. This is incredible. I didn't have even a guess of what is going there. I always thought that the autonomous car is something of very closed labs in Silicon Valley, that car companies were not interested in that because it was something of Tesla and a few like that. But it's amazing how the industry is looking at the future. Cars are not the same as they used to be. Of course, they are not right now. They will not in a few years. And I think that I'm confident that we will solve all the problems, no, about the chip industry, the communications, and the energy, even the energy, Guillermo. I think that in 50 years we won't see that, but in 50 years we will have the energy solved as well.
I mean, if you think what the gaps explain right now, you know, the company that did Windows 3.1 is actually building all the infrastructure for the you know for all the cars, you know, and that it's like
Things advance very quickly, very quickly. And the pace of technology is going like
but
this.
one day we can talk about the Windows technology, because the Windows technology is much better, and I know it very well inside, you know, much better than the people think. But what I wanted to say is that, you know, if you think about how the evolution of the world, you know, that the company that, you know, did Windows 3.1 is the company, and, you know, and MS-DOS is a company now that is driving the data models that company cars are using to do their testings, you know. So that's a huge evolution in the world of technology, you know, if you think about
that's
that.
Right.
But you know, and this is what I wanted to point out. The fact, I know that the bad tongues will say, all right, you cannot trust Microsoft is going to do it well because Windows 3.1. No, I mean about how big is the leap, you know, in the sense of, look, you know, 25 years ago they were dealing with cooperative multi-threading, because it was cooperative multi-threading what they did, something that we can talk about one day, you know, which is different from preemptive multi-threading. Yeah, you know, those are my keys, you know, and but is the one driving, actually nobody will thought Microsoft is actually driving the models that the car companies are using. This is something one will think more on the lines of Sun Microsystems, you know, or I don't know, you know, maybe even IBM. But I've been working 20 years like you, and I know it's not right for that, but you know, it's huge, you know, the leap that you know,
and
in
it's
technology.
to do also open source.
So that give me trust, and that we're gonna get there.
Been a big push. I mean, most of this stuff is, I mean, today we run more Linux than Windows.
Yeah.
So on the cloud.
I just I cannot say many things anymore because it's very big. This is I've been overwhelmed.
Thank you very much for your time. It's been a pleasure.
I'm gonna say one thing.
Tell us.
I saw no, because it's very funny. It's very funny. I once was in a in a in a conference of a guy saying things about machine learning and autonomous car driving, and then there was the question, and then someone asked a person that wasn't related at all with it, and they say, what do you think of autonomous cars? And the guy say, well, if my brother can drive a car, so will a machine.
Okay, guys,
Thank
it's
you.
been a pleasure, Gabs, having you here. Thanks a lot. You are invited every time you want to.
Great to come
Not
back.
only to speak, and you want to join and chat with us. You're invited. Felix, Guillermo, thank you a lot. Thank you very much. Hope to see you again in the next chapter. Conchi is silently listening all the time. Conchi, thank you very much.
Very, very interesting speaking. Thank you very much.
Thank you.
Okay, guys. See you.
Thank you,
Okay.
guys.
Gabs, I want to be like you when I grow old. Bye bye.
See you.
Bye.
Bye. Thank you very much.
Bye bye.